And there's a problem with flood in the way that it applies itself. So if this were the ground surface, we've got to have a gradient with flood, and we're going to put water down a ditch down this system. The water is going to penetrate into the soil like this. At the upper end of the field, where we start with the water, it's going to be very deep. But as we get toward the end of the field, it gets less and less and less and less and less till the end of the field gets very little. Now if we allow this to go on over a period of time, this curve just keeps increasing like this, downward. So what happens now, see, this is the end of the field. All of this water now is runoff if we keep irrigating. Now we finally got this to deep enough moisture at the end of the field. All of this water, if this was our depth that we wanted to get to, all of the water below here, that's all deep percolation. And we've lost that water, and over here we have runoff. So with furrow irrigation, you just oftentimes can never win. To get equal distribution down that ditch is real hard to do. Now there are some methods that they use to help compensate for this. One thing is they use a surge process. They'll put water in the ditch at a very high rate of flow and then shut it off. Run it for a few minutes, shut it off. Let it shut off for a few minutes and surge it again. So they're putting water at a very fast rate, trying to get it to run all the way to the end of the ditch, and then stop it, let that soak in before they do it again. And they keep doing that cycle after cycle after cycle, surging the ditch, trying to get it down the ditch real fast so it's uniformly distributed before it soaks in.
So it don't go down in deep percolation, right?
Exactly.
Siphon tubes flood too.
Siphon tubes would be a form of flood, absolutely. So this could be a ditch here with a siphon tube filling in a...
Would that drawing be also, would it relate to siphon tubes as well?
Oh, absolutely, because this would be the furrow coming down here. I just drew the ground surface. This would actually be the furrow. This would be the head ditch or a gated pipe or something like that up here.
Okay.
Feeding it. Yeah, it could be a head ditch with a siphon tube into the furrow, or it could be a gated pipe that we just slide the gate open to fill the furrow. There's a few ways to do that. But we end up with these two problems: deep runoff, deep percolation, or runoff out the end of the field. Another thing that they've done is they put an additive into the water called PAM. That's a PAM. It's some kind of, it's kind of reminds you of cornstarch almost, yeah. And but what it does is it kind of acts as a ditch liner modifier. It kind of makes the soil more uniform at the way it accepts water as it goes down the furrow. And that's a way to do it. Another thing they've done is they've taken the runoff water and recycle it back up to the head of the ditch. Set up a tailwater pond, pick up that tailwater that comes out the end of the furrow, and recycle it back up to the head ditch again, so that they're not losing that water out of that particular field. So there's some things that they can do to improve those efficiencies.